Alright, welcome back to another advent of code, and today let's solve day 20 called race condition. And yeah, I guess today is another maze finding like the path day, and yeah, I guess I'm gonna use Golang for this one. And the idea for today is that again, we want to go from the start position to the end position, so it's the same like input parsing. I guess I already forgot which day it was, but we can try to figure that one out later. But we have the track, which is a dot, and walls, which are hash symbols. And what seems easier this time is that each move, going up, down, left, right, takes only one step, so that's gonna be the weight. But we can have like a cheat, because it's like really small in a computer, so it can go through walls for some reason. And the rules are very strict for cheating. You can do it only once during a race, and what you can do is disable collisions with the walls for 2 picoseconds. So that means you can go through walls once. So you can disable the collisions only once. I don't think you can like disable them here and then again here, right? You do either one step or 2 steps at once. So for instance, a program could complete the course in 72 picoseconds, saving 12 picoseconds by cheating on the 2 moves marked 1 and 2. Or a program can complete the course in 64 picoseconds by cheating here, and that's yeah, here. I want to see if there are any time like 2 of them, so I guess they never show that. Oh, so once can be done here, for instance, but I'm just wondering if there is like so you can only skip one wall then, because it says that this allows the program to pass through walls if they were a regular track. At the end of the cheat, the program must be back on normal track again. But I don't see in the examples if you can actually go to a too wide wall, but I think you cannot. So here is our puzzle input. So what we'll be able to do is have like let's say we'll still use Dijkstra, obviously. We cannot really use anything else. I mean, maybe we could use a star. But I think Dijkstra is better in this case. So we'll have let's say a flag, or maybe just an integer. That's like how I mean, it should be a flag though, of if you can actually, like, let's say, ignore a wall. So if that flag is true, it means you can ignore the wall. And based on that, right, based on that, you should be able to compute like the new neighbors, right? So I guess so if you remember, I think day 16 was the one with Dijkstra. So here we did neighbors, right? Parsing the input, as I said, it should be kind of the same. Right, and in the here we had directions as an extra thing, but I think that for now what we'll do is have again the start position, and the extra thing will be if we cheated or not. right? Or it should be the cheat counter, let's say. So let's say that it says you cheated I mean, I'm wondering what, like, hopefully part 2 is not gonna be, okay, you can cheat actually for 10 picoseconds, like, that's kind of just, yeah, I don't think that's gonna be, so, yeah, then I guess we can have just a boolean here, which is gonna say, okay, you can actually just cheat, uh, let's say, for the next move, so the priority queue is gonna be similar. And yeah, we'll just solve it like this with Dijkstra. And I mean, I want to use Golang because Golang collections heap, it already has a heap. So I just want to see, I mean, it should be a bit easy. Maybe it's going to be easier in Golang because you might be able to implement a function for sorting, right? So you might be able to have like an actual sorting. It's not gonna be like in Python where you have to put the cost and yeah. So I guess let's try it. Let's try to solve today's problem in Golang. So already have the this one. Let me just download next run. Let's try to download the input. Let's go to day 20. I'm gonna still use tmp file. So it's gonna be something like go run tmp. Alright, so golang read. I mean, it should be pretty straightforward to do that in Golang. From what I remember, you have to do something like this. Alright, so that will print each line. It's weird, why is it? Okay. So basically something like this. And let's just have a function parse input, and just by looking at this other one, I would say we need the width, the height. Puzzle used to be something like a hash map. The puzzle was a hash map, if I remember correctly. Yeah, the puzzle was like a hash map and it had point and direction, but now I said we'll have point and cheat is equal to false or something like that. I mean, I guess not really. It's just gonna be, so we'll do this thing, then we'll have height equals to 0, width is equal to 0. Can I just return with height? All right. Wait, was it that's something I forgot about. Okay, yeah, just like that. So that's how we get the int, the width and height. But I also want to have like the puzzle, which is gonna be, I can use make, and here we can have a map. And you can have, so the puzzle map, I think in my my code was, it was a bit weird because it was the neighbors that I can reach. So here I was actually generating the neighbors. But I don't know if I want to do that already. Maybe I do though. Maybe that's what I want to do. Generate the neighbors from beforehand. Interesting. Can I have like int as a so I don't remember Golang hash map. Like how do you actually write a map? Okay, so that's the key and then the value. So the value should be, so if I want, yeah, so basically if I want the cheating thing, I might have to put the boolean into this. So maybe I can call this one neighbors, right? And what should be the, let's maybe do like type. Vec2 is gonna be int. Wait, how do you Golang type alias? I forgot about this one. How do you make a type alias? Yeah, I thought that's the way to do it. Weird. Huh. Golang people type. Yeah, whatever. We'll just use it like this. So here we get, so we'll have like a position, right? And then we need the, let's just say, and maybe it's not needed to just generate all the neighbors from the beginning. Like, what's the point? Maybe I'm just gonna have the map, or I guess the puzzle, because map is a keyword, is just gonna be a string list. Or wait, how do you write that? Yes. Oh, I meant it's gonna be a string list. Wait. Huh. Strange. Golang declare list or an array. I mean, that was the most useless. Hmm. dynamic array. So like this, that's what I wanted to do. What string is not an expression? What? I mean, I see that you can say like puzzle string like this, but whatever. So then should I just, I mean, I think that makes sense just to have a, so let's use append puzzle and we append scanner dot text, right? And I have to say puzzle is equal to, okay. So here we just read this thing. Now to get the, I guess the width and the height are just gonna be from the puzzle itself, so I might not even have to do any of that. So yeah, let's just return the puzzle. So that's just gonna give us the puzzle as a list. Parse input, and that's kind of it. So yeah, let's try to do it straight into part one. So function part one is gonna take in the puzzle. We'll just return like that. Then here dist was a dictionary, so I guess dist can be a map from int boolean to like the cost. I have to use make or something. Jesus, what? Var? Yeah, I mean, that's what I tried. But cannot I just put here int bool? I cannot. But I mean, I can have a struct. Let's just call it point, and it's gonna be row int, column int, and sheet boolean or something. Wait, what? Long struct. You put the name afterwards? Oh, it's type point struct. So what if I put here point? That seems to work. So yeah, Maybe that's what we want to have as the dist, right? So the distance is going to be just a hash map from row column and if we cheated or not to the distance. So we need to know if we cheated or not already, because if we cheated then we cannot cheat anymore, right? We can only cheat once. And then we need the priority queue. So if we look at how to use heap queue, there was an example or something, I guess. Example for priority queue. So we'll have an item for our priority queue, and those are going to be basically the neighbors, kind of, right? So these things should have the value and the priority. So the priority is gonna be basically the distance, kind of. So let's say priority is an integer and the point is a point. All right, that's what I think it should look like in the priority queue. And then priority queue is just, let's see. So priority queue is that we'll have a length. I mean, I'm just copying from the docs, right? So priority queue less ij, we want to pop. So here we just compare the priorities, and it also needs the index. Okay, so let's also put the index. All right, so then we need the less function for our priority queue. We need a swap function, a push, a pop, an update. I mean, this should be, in my opinion, some function in stdlib, but it is what it is. So let's import this thing. So we still have an error here because we call this thing point actually, and this should be point, and this should also be point, and this should be point as well. All right, so update modifies the priority, I think. Interesting. Push. So here it works to say any or something. Okay, fair enough. Okay, whatever. So these ones are just that. So if we have items, okay, we can make a priority queue, but I'm not sure like what should be the length of that priority queue. I guess at first it should be only 1 because we want to add only 0 start. Right. Oh, and that's true. Maybe this should be just like read input, and then we can have another function that's gonna, so let's put here 1. Right, and then I can say something like pq of 0. It's gonna be, wait, it does have a 0 thing. I mean, yeah, because it's a list. So this should be, it says here an item, and we can put basically priority is 0 for the start, then point it should be something, but we don't know yet what it's gonna look like, and index 0 because it's the first item. Alright, then we heap init, heap dot init our pq, and let's have a function for parse input actually. So this is gonna take in the puzzle. I always like to put that. So it's gonna take in the puzzle. We have to think about what do we want to return from this one. Because yeah, like generating all the neighbors might be a good idea though. It might be a good idea. I might want to just return the like int for the width and the height. I guess easiest is to say height is len puzzle, and the width is gonna be just len puzzle 0 or something. But yeah, we need to generate all the... Wait, what? We need to generate all the neighbors now, and that's gonna be annoying. I guess the first thing we need to do is to find the start and the end positions as well. So the start position, it should be a point, the start position. The end position doesn't really matter, it can be just int for the row and the column. But I see it doesn't like that. So we can put another point here, and it doesn't matter that it's a cheat false or true. It can be either one. But in fact, it should be like, because you know what it asks here? How many cheats would save you at least 100 picoseconds? So how many would save you at least? So if a cheat doesn't save you anything, then you don't even consider it. So then it means we have to solve the problem with and without cheating. So we care about, I mean, we don't really care that, you know, whatever. But how are we gonna generate these neighbors though? That's gonna be the part that sucks the most. So in the Python version, I was just iterating. So I was starting with this puzzle start end, right? So let's do the same. Neighbors. It was basically make, or wait, where did I try to write it? I don't remember. I can say var neighbors, and we'll try to make a map from point. How about we make it to points? So it's like from one point you can go to multiple points. Makes sense. Then we'll have a variable for the start, which is a point, a variable for the end, which is a point. And here we are going to return start, end, and neighbors. Let me just copy paste this one here and save. Okay, so these are going to be null, but it's not really an issue. So let's say we are gonna do a Golang for range. How can we make a for? Okay. For loop, I guess. For loop. So it's just a for loop. So for row is equal to 0, row is less than the height, row plus plus. We should be able to do some stuff. Maybe if we do for column is equal to 0, column is less than width, column plus plus, and we are gonna we just need to take the character from the maybe like ch is equal to puzzle row column, and what is ch is a byte. So if ch is equal to s, then start should be a point. Can I just say a row? I think I can. A row column and sheet. False. Yeah. And then else. Else if ch is an e, then we can put the endpoint, that position. And here it doesn't really matter what sheet is, but maybe this is gonna make it more obvious that it doesn't matter. So yeah, right. But it's the same thing as we did here. Then if it's not empty, what is empty? I was skipping the things. Okay. So I was actually skipping these. But in this case, I don't really want to skip them, let's say, necessarily. So what I should do instead, so if it's an else case, right? At this point, we are either on a dot or a hash. So if we are on a dot, then we can do stuff normally. But if we are on a hash symbol, we have to set cheat to true, basically. Let's think. So if we are on a normal square, let's do the normal square first. So if ch is equal to no, so it's not really like that. It's more like if it's a hash, we do something, and then else is the normal stuff. So if it's the normal stuff, what we are gonna do is something similar to the Python version. We generate the neighbors, and we need this function to check if it's bounded. So function is bounded, takes in a p point with int height int, and is gonna return a boolean. So is bounded is just return 0 is less than or equal to p row, and p row is less than or equal to height, I guess less than, and 0 is less than or equal to p column, and p column is less than width, so that's is bounded, right? Now the is empty one I don't really care, so what we can do here is maybe like can I have like const directions, something like this. So I can say that, but const golang const array. Like I want a constant array. I need to specify the type. But really, like Golang tuple, it doesn't have tuples. That's weird. I mean, I can say like this structure. Right, but without that. Wait, what? Is interface. I mean, it is what it is. We can just use point. So it's gonna be points here. So we'll have like 0.10, or I guess a row. Wait, if I say 10, what is it gonna say? Jesus. Oh, you know what? It's like this. But how do I put 10 inside? And then how do I use it? Directions. Invalid type. Okay, so let's make it an array of points then. Still fucking invalid type. Okay, whatever, I don't really care about that. what if we make a function that returns the neighbors? So something like get neighbors takes in a point and it gives me back a list of points or something. Dude, why is my LSP broken for some? Also, it was broken because of this shit. Oh my god. Ah, so it doesn't like to have okay, it wants it like this. Fine. Oh wait, can I just say for... Oh, I can actually just put false. Okay, fine. Const directions. And why didn't it work when I tried struct int? So if I just say point, it's not constant. Okay, fair enough. Let's have like a function here. So I'm gonna say something like return point, and we can build like an array here, and it's just gonna be basically point row -1 b column. So I'm gonna do it, and let's just put false for now in the... So here it's gonna be plus minus. So these are gonna be the neighbors. All right. So then what does this mean is we can generate the neighbors here for an empty space, and that's gonna give us a list of points. And that's gonna give us a list of the points. But what do I want is if a point is gonna be blocked. So I have here filter is empty. So maybe is empty is still kind of needed, but who cares? So if it's gonna be a hash, then we just set cheat to true. Right. We just set cheat to true. So maybe okay, let's do a for loop. So for in range get neighbors, and the point is gonna be basically... Wait, let's do p is equal to point row column false, So we get the neighbors of this point. This is gonna be a point. So if it's out of bounds, then we don't even look at it. So if it's not bounded, the neighbor with width and height, we just continue. Or something. I guess we need the neighbors. So we have already a map, so neighbors map. So can I just say neighbors of P is equal to this thing? So we make like we basically insert the neighbors in there or something like that. So if it's not bounded, we skip it. Otherwise, we are gonna add it. But maybe we need an extra if statement, and it's gonna be like if puzzle of n dot row n dot column is equal to a hash symbol, then n dot cheat is equal to true. Right, so if the neighbor is on top of a hash symbol, then we make cheat true. And the reason is that here it started already with false, so we just make it true. And then at the end we just say neighbors of P is equal to append neighbors. It's no, the LSP of Golang is really nice, like it gives you really good suggestions. You just saw that. So neighbors P is gonna be this append, and for the hash symbol we already start with so let's just say this should be defined beforehand clearly, like it makes more sense. Then in the if case, oops, we have something similar. We should have something similar in the if case, but if we find another hash symbol, then we cannot even cheat anymore, because right, we cannot even cheat. Maybe it makes even more sense to do it like this, and here if it's that one, it's cheat true, and here it's cheat false for the point. So here it's gonna be cheat is equal to true. Right, so that's the first case. Here it's only cheat true if you are on a hash symbol. So if the neighbor is a hash, then you just continue, cannot do anything about it. Otherwise n.cheat is always true in this case, doesn't matter because it was already true here. But here on the other case we have two cases. One when the point is cheat is equal to true, and one when the point is equal to cheat is equal to false. So I think we need to do the second one too. So p2 but the thing is we can even just do it at the same time. So p2 is gonna be cheat is equal to true. So let's say P2 is happening here, right? We already cheated for P2, so we cannot cheat again because it's already true. So I guess that means that for P2 we need to do it on the else case, and on the else case n.cheat is always true. So here on the else case n.cheat is always true, but I need to create a new point. So point and row and column true. Alright, something like that. I don't know, it's so bad, but maybe it's gonna work. So it's like if we find the hash symbol, then automatically the point is like it's cheating. And for the neighbors, we only keep the neighbors that are dots or whatever. And then on the else case, if we found an empty space, then we have two cases. Either that empty space is still non-cheating, or it is, we already cheated at some point in the past. And then for each neighbor, if it's bounded, if it's not bounded, we cannot do anything. Then if it's a hash symbol, we have the two cases, the non-cheating case and the cheating case. If it's non-cheating, then we just make the point cheating and we append it to neighbors. Otherwise, we can only append it here if it's non-cheating. Insane. Okay, so this. Let's see. So I'm gonna do parse input of puzzle, and parse input gives us width, height, start, end, and I'm gonna call it neighbors. Can I just print the neighbors? Width, height, start, and end. Can I just print all of these? I guess I want to do part 1 puzzle. Assignment to entry in nil map. So do I have to say is equal to big map? Index out of range. At 59 or something. Wait, what the fuck? No, it looks good, but what? Is that insane? I don't get it. Why does it show an error there with like range 0, index length 0? What the fuck? Puzzle end of the row. Oh, it's the fucking yeah. So here is the extra new line at the end. So I can say like line is equal to scanner text if len line is greater than 0, then that's when we append to the puzzle. Okay, so it actually generates some stuff. That's kind of fine. So, but it's so huge. Okay. Let's see if we can see something interesting for the start point. So what if we try to access the start? What if we try to access the start? So for start, we can go to 2-1 by not cheating. All right, so start 2-1 should be up, I guess. Yeah, and then 4-1 by cheating, 3-0 by cheating, and 3-2 by cheating. That's kind of interesting, not gonna lie. So then I'm curious about 3-2, let's say. I'm curious about 3-2. So here, if I say point 3-2 true, so what would you be able to do from that point is go to 3-1 by cheating, so back basically, or 3-3 by cheating. Okay, so it looks like this thing works, right? It looks like it kind of works. So that gives me some hope, at least. All right, so we kind of generated the neighbors, so we are good on that part. So now while, or I guess for len eq is greater than 0, so while the queue is not empty, we have to heap pop. So we have pq dot pop, and this one, I mean, honestly, I don't want to return like any and stuff like that, because I already know that here it's a point. Or no, oh, this is an entire item or something. But this returns me an item, so why did they put here? Oh, so it's item pointer. Yeah, but I'm curious, why did they? Why did they show it with any there, but whatever. Ah, because, yeah, okay. I get it. So the interface itself returns any. So I have to cast it to... It's kind of annoying. So let's just say, what do we get from this one? We should get an item. So let's call it current. If u is in dist, we continue. So if go and check if map contains key. Okay, so I can do something like this, but we won't care about the only about the okay. So dist current point. So if it's okay, then we continue, right? But if we don't have it, then we have to add it in the dist. So dist of current point should be equal to the priority, current priority. And then for each neighbor, so for something like that, and n in range neighbors of current point, right? We get a neighbor, and if the neighbor is not in dist, we have to add it. So we have to do the same thing. Okay is equal to dist of n if okay continue. If not, we have to heap push. So we have to push, and the cost is gonna be basically cost plus 1. So priority plus 1. And v is the neighbor. So I just have to say pq.push item. It's interesting. So push. Okay, so the index is set automatically. Interesting. So here I can just say push item, and let's say priority is gonna be current priority plus 1 because it's one more step. Then the point is gonna be the neighbor, and the index can be 0 because it's overwritten anyways. So I think that's how it should be. And here it complains that we don't use start because, yeah, in fact we don't use start. And the end. Wait, how did I use end here? I guess I just took the distance of end. But annoyingly enough, this just gives me the like I will get the smallest distance. I mean, it's good enough for now. We just get the distance by not cheating, let's say. So these guys are not used. Really. So result. Oh, so here it wants address, I guess, in 120. Yeah, 173. So yeah, I guess the minimum distance by not cheating, it really was 84, right? And let's see, I'm curious, what if we say end.cheat is equal to true? Like, what's the best one? 80. Which I don't think it is. I don't think 80 was the best one. So it's not even close then, I guess. I mean, it is what it is. Right. So I guess maybe I'm doing something wrong. Maybe I guess it should be much easier to solve. So let's just try to remove everything that's related to okay, where's the point definition? So I was just thinking, what if we do another approach for the cheating thing? What if we keep everything as not cheating, so we don't care about cheating, we don't simulate that. So for instance, if it's start end, that's when we do that. If it's a hash symbol, then we just continue because we cannot generate neighbors for them. And in here we only do this one, then we do get neighbors. If the neighbor is like that, we continue. So basically it's just day 16, right? At this point it's just day 16, right? So we have the start and end points. We just go from start to end. If it's a hash symbol, we cannot have neighbors for that. Makes sense. And if it's a simple point, we just do a point, like we get a point, and if it's a free space, right, we check if its neighbors are bounded. If it's bounded, then it's fine. If it's a hash symbol, so it's a wall, then we cannot go there, so we just continue, and the neighbors are going to be just the neighbors that we can reach, right? So another empty space. So that means that all of this stuff with priority queue stays the same. So this is like a small library. Again, like this should be part of like Golang, but it's not, so this is what it is. Anyway, all right, so at this point, part one, what is it gonna do is create the distance map, start and neighbors, priority queue. We get this stuff, so we get the distances. So in the end, what if we, let's call this one Dijkstra, and let's make it return this hash map. So we return the distances hash map. So Dijkstra. Let's take a look at dist. Let's take a look at the dist map. So dist map, shit, and it's not used. Okay, fair enough. Let's take a look at the dist map. So you can see that to reach 1 1 from the start position, it's a cost of 2. To reach 1 2, it's a cost of 3. And I guess if we scan through this thing, we should see that the cost to get to the end position is gonna be 84. So like it's 82 here. The question is, can we find maybe, so for instance, this point right here, the 3 2 1. So do I have a 0 cost? I guess Dijkstra, it's a stupid idea to do that, but let's just parse the entire input here, and Dijkstra is gonna get just neighbors and start. So Dijkstra is just gonna take in neighbors and start point, but neighbors, it should be, where is it? Wait, it's this thing, and that's the neighbors. Alright, so that's how Dijkstra should work. It takes in the neighbors and the start point, and it gives us all the distances. Alright, do we see the one with distance 0? I don't see it, but it should be like 3, 1. So if we take a look, so if we do print of start, we should see 3, 1 is 0, right? And if we check out point, so this is like 0, 1 the column, 0, 1 the column, 0, 1, 2, 3, 0, 1, 2, 3, so 3, 3. 3, 3 is the this one if we go up, but we can say something like, what would happen if it's like the distance between these 2 points is only 1, right? Or I guess it's 2, which is the jump limit that we can have. So what if we say something like, oh, you can actually optimize this, instead of 6 steps, you can only make 1 step, actually, in fact, right? But how can we use that information? So that means that we might be able to generate some kind of combinations between the points. So kind of like this point can go to this point more efficiently with only 2 steps instead of 6. But I'm more interested about like these ones, for instance. But I think it's the same stuff. So you can go from here to here in only 1 step. So that's gonna optimize the situation. So yeah, let's make a function, part 1. And actually this function is gonna take in the distances. So it's gonna take in the distances. Right, so part 1 is gonna take in the distances. And can I somehow get Golang map keys? Can I get the keys? Can I get the keys? Somewhat. So we can have keys. Dist. And another question is Golang combinations. Oh, it's a package. I don't want it. Well, I mean, to get the combinations pretty easily, we just use 2 for loops. So what I'm gonna do actually then, okay, so then we don't even need that. Then what I'm gonna do, wait, this is not, what the fuck am I doing? This is map point to int. Okay, so let's actually not, we don't need that. We just need to make a for loop. Let's do ij right now, and let's see what I and j are gonna be. So here it's gonna be a point, and this is gonna be the distance. So this is gonna be, let's call it point 1 and distance 1, and then another for loop, p2 distance 2 is equal to range dist. So that way we can get all the combinations. Although this is also jumping backwards, so I'm not sure if it's gonna work. If P1 is different, then no, if it's equal to P2, then we continue because it's the same point. We don't really care about it. But let's make a function for our structure. Function distance is gonna take in P1 point, P2 point. I mean, it's just Manhattan distance. So it's gonna be P1 dot row minus P2 dot row, but we need to get the absolute value. So do we have math dot abs function? We do, plus math dot abs int. Oh, I think that's how it should work, actually. What do you mean? Dude, what? What a joke. What a joke. What a joke is Golang with this stuff. Abs int. Like, I mean, I know I copy pasted this one, but it's just if the numbers are negative, then you just, yeah, whatever. So what I wanted to do is if Manhattan distance between P1 and P2, I guess if it's less than or equal to 2, which is our jump distance, then what if we just say result is equal to 0? What if we say result is equal to result plus 1? And what is the distances for? Well, here it says that if the distance is also if the you know what, let's print optimization. So print ln d1 minus d2. Let's see it. So then I can do something like result is equal to part 1 of this, println result. Alright, so if we run this one, okay, I mean, obviously, interesting. So we get a bunch of distances. It's also negative ones. And there are not that many. So maybe I want to have some kind of order in those. Right, so let's think about it. So if we do d2 minus d1, this is the distance to get from start to point 2, and this is the distance to get from start to point 1. So if we make the subtraction between these two, we get like the cost difference. So that's the cost difference. So saved steps. I think the amount of steps that we save is, so let's say we look at our previous example with it was 0 and 6, right? So the amount of steps that we save is 6 minus 0 minus the 2 steps we make through the wall. So I think it's minus steps or something. So if steps is less than 2, and yeah, I think if saved is more than 100 was the thingy, right? But in this one it's 0, but in our input 20, a lot of them are negative. Oh, because I'm printing the wrong thing, so save. Now what, I'm not sure if it's if we should divide by 2 this answer. Like, to me it looks way too big, but I haven't looked at the puzzle. I mean, you might think it's too big, but yo, what the fuck? Huh. I really thought it needs to be divided by 2, to be honest with you. I'm a bit surprised that it actually just worked with just that. I thought it's gonna need divide by 2 because here it's gonna be both orders, but maybe just by doing the modulo, the absolute value on the distance here, and also checking if it's greater than 100 and not, oh, you know why? Because saved, the number of saved steps, I haven't used the like absolute value on it. So if I do abs int here on this thing, well, actually I have to do it on this only. If I do it like this, it's gonna be double the size. Yeah, so that was the trick, right? By not doing the absolute value on the difference. So here we basically say that P1 is smaller than P2, if you know what I mean, in this for loop. So basically, usually when you do combinations in math, you take P1 and then all the P2s that are higher in the list, right? So it's like when you do bubble sort, it's for I is equal to 0, blah blah blah, and then for j is equal to I plus 1. That's what I was trying to do here. But apparently just by not doing the absolute value for d1 and d2, it's enough. That's pretty cool. So what's part 2 about? A single cheat that lasts at most 20 picoseconds. Almost as good as me. 20 picoseconds, that's a record. So okay, so instead of 2 picoseconds, we want to use 20 picoseconds. So I mean steps int, and then, oh, I guess picoseconds, and here I'm gonna say pico. So part 1 is using 2 picoseconds and part 2 is using 20. Right, I think that's the only difference maybe. And didn't I just say that's gonna happen? I think I did. Wait, how the fuck is it more? I guess it's more if you think about it, because you can just zap to the end. Yeah, and it actually was. Yeah, I mean, it actually makes sense that it's more of them. Interesting. So in the end I was a bit tricked in the beginning, like I went into a rabbit hole, by thinking that I have to actually simulate the jumping, but it actually was just a matter of doing Dijkstra. So we just did the Dijkstra algorithm as uh, you know, like the usual Dijkstra. The only difficult part would have been implementing priority queue, but that's just I copy pasted from the Golang docs. So I like it should be part of the stdlib, but it's not for some reason. It is what it is though. And the trick that we used, so we just used Dijkstra to get all the distances, right? The on the entire map. And then the trick was actually we didn't even need it, the end position, believe it or not. We didn't even need it. The only thing that we needed was to check basically if between two steps, so we just choose two steps on the map and we check, can we reach from this step to this step by teleporting? Basically, can we teleport from one step to the other? And if the answer is yes, then we see, okay, how many steps would we save if we teleported from one step to the other? I mean, yeah, I think that it was an interesting one. It was really confusing at first, but luckily enough, luckily enough, the second part was easy. If you did part one like this, like, yeah, just thinking about it, nah, that my initial solution would have been would have sucked. Not gonna lie, to do part two in that. But yeah, so that's kind of it for today. So hopefully you enjoy this one. And yeah, I mean, I guess, it's like from now on, probably all problems will be solved with Dijkstra or A star or something like that. So um, obviously, my first instinct was to just use Dijkstra, so at least that was right. But yeah, that's it for today, and we'll see you in the next one. So see you.